record. Okay, all right, so we're going to be in chapter 6 on page 229. Okay, the exponential functions that are in the blue box, they're going to start with an a of 1 to begin with, right? And so that multiplier will come in later, but we're not going to talk about it in this initial part. So basically we have b to the x power, and the exponent is the variable. B is the base number. It is going to be a constant throughout that particular problem, that particular graph. Okay, so if we use what's at the top, where it says y equals 2 to the x. If x is 1, 2 to the first power is 2, and so we have 1 comma 2 as a point on the graph. If x is 2, we'll have 2 to the second power, which is 4, right? 2 comma 4 point on the graph. And if it's 3, we'll have 3 comma 8 as a point on the graph. Now, when the x's go in the negative direction, it's not a positive or negative change, it's the side of the fraction change. So 2 to the negative 1 power is 1 over 2 to the first, which is 1/2. So negative 1 comma 1/2 is a point on the graph. And then if it's negative 2, it'll be 1 over 2 to the second, 1 over 4. So it'll be negative 2 comma 1/4. Now, what happens if I have negative 25? It'll be 2 to the negative 25th power, which is really, really small, and it's going to begin to approach 0. All right, we're going to see that on the graph in just a minute over here. And if it was 2 to the 25th power, it would be a large number, and it would be approaching infinity. That's represented by the arrow going on this side of the graph, if you see it. So this particular part here, this is a graph of 2 to the x power, and they actually show it right here. All right, now, so the thing that we haven't talked about is what happens when x is 0. When x is, what is 2 to the 0 power? It's 1. Any number to the 0 power is 1. And so the graph is going to go through 0, 1. Now, to be able to determine whether or not a is some other value than 1, you look at when x is 0, you should be at 1. If you're at something else, then that means that we have a change. It's not just 2 to the x power. There's something else going on. And when x is 1, if the base number was 2, we should be at that base number because 2 to the first power is 2. If those numbers are different, then we have to begin to figure out algebraically what's happened. Okay? Now, here's something that we'll get to later. All right, this graph in the middle is y equals x to the x power. So y equals 2 to the x power. That's this graph in the middle. All right, look at this right here. Can you see it on the board? This says 2 to the x plus 3. All right, this dotted line where we are approaching 0 is called the asymptote, if you remember. And the asymptote was moved up 3 because of this plus 3. And the point 0, 1 is now at 0, 4. It's moved up 3. So the number that's on the outside is a vertical shift. All right, and here's another example. This is 2x minus 3. So what was the 0 line that we approached is now at negative 3. And the 1 is now down to negative 2. And so that becomes that. So the number on the outside is a vertical shift up and down of the entire graph. So the asymptote moves and that point 0, 1 moves. Okay? Now, all right, here's a different example. All right, the green, if we do this, do you notice 0, 1, all the points are going through 0, 1? All right, but when x is 1, it looks like we get 1, 8. So what's the base number? The base number is 8.
because 8 to the first power is 8. 8 to the second power is 16, and it's way off of there. Okay, but the blue one, when x is 1, I get 1 comma 2, and then I get 2 comma 4. Right? So this blue one is 2 to the x power, but the other one, the green one, appears to be 8 to the x power. All right, now let's look at this one. Here, when x is negative 1, I have a 2. That means I have 1/2 raised to the negative 1 power. And what happens to the 2 to the negative 1 power? When it's 1/2, the 2 comes to the front. So negative 1 comma 2 means that the red graph is 1/2 raised to the x power. All right, now what do you notice about the blue one and the red one?
They're the same but opposite.
All right, so they are reflections, right? They're inverses of each other, right? It's a reflection across the y-axis. Okay, now, and we'll get into that in more details. All right, so if you're trying to figure it out, it's got to go through 0, 0. I'm sorry, 0, 1. If it doesn't go through 0, 1, then you've had an extra number on the outside, or you've had a multiplier with the a. All right, what did I just say? If it's not 0, comma 1, right at this point right here, then you've either had the a is a multiplier that's not 1, or you've had an extra number on the outside and had a vertical shift. All right. How do we know that the green is not a vertical shift? Is that the asymptote is the x-axis where we expect it. If the asymptote was something else, then you would have expected a shift with the extra number, the vertical shift, or a shift that's affected by the a. Okay. All right. Now, so that takes care of part number 1, and those on page 230. There's 5 numbers, and it's just exploring. All right, now, okay, on page 231, I've just talked about that particular graph. If the values are not whole numbers, how would you find out what it was? If the value is not a whole number. You'd use the raise to button, right? And you'd raise it to whatever that power was, and you could find it. It would probably be an irrational number, so you'd have to estimate it to the fourth decimal place. All right, but most of that is not new. All right, so if we turn over on page 232, I don't think this is new for you. Base, exponent, and power is vocabulary words. All right, but the agreement on the bottom of 232. All right, we are going to agree that the exponent affects only the variable that it is complementing. If it is supposed to affect more than one variable, then you have to use parentheses. All right, so in the first one, it says parentheses xy to the 5th means that that 5th power goes into both the x and the y. And the same thing would be true with negative x raised to the 5th power. You would have 5 negative x's. All right? But in the second group, where it says xy to the 5th is only affecting the y. It doesn't affect the x, because it's still x to the first power. All right, you see that? Okay, now that's agreement, and so you've got to be careful that you do the mathematics correctly. All right, now turn one more page, 235, or I'm sorry, 234. All right, again, this is mainly calculator work, so that you see what we just talked about in that blue box about what's affected. You'll see it with the calculator. So in problem number 1, which 2 of those, A, B, or C, which 2 of those will give you the same answer?
B and C.
See, it's B and C? Right, okay. All right, what about problem 2?
B and C.
B and C, okay? So you would go down through that and begin to see with the calculator to verify that that's actually true. And then you're going to do a few on the next page, which is just evaluating. Most of that, I think, you're more than familiar with. Like in problem 17, you have x to the 5th in parentheses raised to the 3rd power. How many x's will you have altogether?
8.
You'll have 3 groups of 15, so it will be, you have 3 groups of 5, so you have 15 of them. All right? In order to get 8, you would have to have x to the 5th times x to the 3rd. Then I'd have 5 in the first and 3 in the second for a total of 8. All right, so power of a power is what number 17 is called, and that you multiply exponents. But when you have, in problem 15, when you have two powers that are multiplied, the product of 2 powers, you add the exponents. All right, but all that is algebra 1, right? All right, so that's just a reminder of what you've done in algebra 1. Okay, now turn over one more page, 236. All right, on 236 we have properties of exponents. In 237 we got a blue box. All right, I'm going to ask you, if you would, to be able to write the equations in the blue box. You see how the equations are set up? Most of these you already know. All right, the first one, the product of 2 powers, you have to write A plus B as the exponents. Now, why is that needed? All right, if I gave you 2 to the 4th times 2 to the 2nd, what would you write? You'd write 2 to the 4 plus 2 equals 2 to the 6th. All right, and that's how you would prove that you have the right answer. All right, now, for a quotient, you're going to subtract the A and the B. All right, so if you had 2 to the 2nd divided by 2 to the -4, you would have 2 to the 2 minus -4, which is 2 to the 6th. All right, and so if you understand that those particular exponents will help you when the integers are not straightforward, all right, when they get a little bit more complicated. And on SAT questions, sometimes those exponents are actually algebraic expressions. Okay. So if in number 2, the quotient of 2 powers, if the first was, if A was W plus 5 and B was W minus 15, what would the overall power be? It would be W minus 5 minus W plus 15, and it would end up being 10. All right, and that's an SAT question. That if you know how to write these equations for each of these powers, then they're going to give you more than just A minus B. They're going to give you something that's harder. All right, but it's an algebra skill, but it's just set up to where it looks crazy. All right, and then power of a power. Now, power of a product. All right, some people say 4 and 5 are distributing. All right, here's why. In problem 4, it's power of a power on page 237. What is the exponent of the x and the y inside the parentheses?
1.
It's 1, right? It's 1x and 1y. And what does the a do? The a distributes into the power. So suppose that the inside was x to the 3rd and y to the 2nd, and then you had some number on the outside. That number, the power on the outside, would distribute into the powers on the inside. And the same thing is true with a quotient. The A that's on the outside distributes. So it doesn't have to be just first power. It would, and if it distributed, it'd be like rule number 1. Okay, now turn to page 239. All right, problem 3. All right, what two numbers would you put in the calculator to get the answer?
For number 3.
For number 3. No, don't do it, just tell me. Tell me, what would you put in the calculator for number 3? Wouldn't you put 5 times 16?
Yes.
Now, you could copy it just like it was and you would get the same answer, but it's basically, why is it 5 times 16?
Because the 4 squared.
Because it's negative 4 squared, which is 16. All right? Okay, and so for number 5, what would you get?
You get 6 times
25.
6 times 25, all right? Number 6,
8 times 36.
all right, you would get 3 to the 4th power, which is 9 times 9, 81, and then the first negative will make it negative 81.
Which number is this?
Number 7.
7. Okay,
Oh,
thank you.
Oh,
Sorry.
okay, that makes sense.
We were all looking at 6.
Oh, I'm sorry. No, I was at 7. Right now, problem 11 on page 239. What does the 4 do? Right? The 4 raises the x to the 7th by distributing, and so it will be x to the...
11?
I know this. I'm trying to see if you do. All right, look at problem 11 on page 239. The 4 on the outside distributes, right? So the x to the 7th will become what? X to the 28. Because I have 4 groups of 7. That's 28. All right. What happens to the 5?
There's 4 groups of 5,
So it becomes 5 to the 4th power. 25 times 25 happens to be 625. Not because I did that, but I know that. Okay. All right. So we end up with 625x to the 28th power because the 4 distributes into the x to the 7 and 5 to the 1st. Okay, so what happens in number 12? Now I am going over. In number 12, what does the 4 do? Distributes into the 9, and that makes it 36, and it also distributes into the 3, and so again, 2 3s is 9, so 4 3s is 9 times 9, 81. Okay, now, problem 13, what happens? How many y's do I have altogether? I have 1 y in the first parentheses, and I'm going to end up with 2 y's in the second, so I have a total of
3 y's.
So it's going to be y to the 3rd, and then I'm going to have 49 times 8, whatever that is. Did you get that, Josh? The 49 times 8? Okay.
392.
Okay. All right. See that? All right. Now, with a calculator and with those skills from the previous page, all right, for the rules, that's not that hard, is it? Okay, good. Turn the page. No, they're just a little harder. All right, but again, this is what you've got to be able to do is understand what rule applies, and if you have to take it step by step, then take it step by step. Okay, so that's that page. All right, now 6-4 is the next section. Okay, turn over to page 242. All right, and let me look here. I don't think I got that for you, did I? No. Okay, so look up on the board right here for a second. Okay, the product rule, this was rule number 1, and I said you need to be able to write this. Some of them you could get, but if you had a problem like here, you have to just add those exponents if the base numbers are the same. Okay, and so this, and then the second one, when you divide them, all right, you're going to subtract them. And I have had places where it's been real important to be able to write it that way. If the integers are negative integers and things like that, that sometimes writing the math arithmetic problem up here, the 5 minus 3, if it was -5 minus -3, it might be real good to write that out so that you don't make a silly mistake with the adding the integers or the subtracting of the integers. So that's these two rules. And then the power rule, all right, the negative exponent rule, all right, this one's really important, is that to get rid of the negative sign in an exponent, you move the whole thing to the other side of the fraction. So if you have a negative on the x, it's 1 over a to the x, and we use that when we were talking about what the graph looks like. But it would also be true if I had another problem that down here where my cursor is, if this was a -4, if this was a to the -4 down here, do I see where I'm pointing? If this was a to the -4, how do I get rid of that negative that is here down in the denominator? I move the a to the 4th to the top. And then the other rule, the zero rule. Okay. All right, so in the last section, we've already been through this, that it distributes. So now we're here. Okay, so x to the -2, I want you to look at this. If the answer is -2, isn't that 0 minus 2? Isn't 0 minus 2 -2?
Yes.
So the first power and the second power are the same, all right? But with this minus sign here, that's the division rule. So I have x to the 0 power in the numerator and x to the second power in the denominator. See? Because if you had this, you would say 0 minus 2 is -2. Right? But what is x to the 0 power?
1.
It's 1. So the negative that's up here ended up being a positive in the denominator over at the end. So that's how you get rid of the negative. This is the proof of it mathematically. Okay? So if you have a -a, it goes to the bottom to get rid of the negative sign. It's not talking about positive and negative. It's talking about the location, whether or not you're multiplying or you're dividing. All right? And then the same thing would be true if you have 1 over x to the -b, that becomes x to the positive b in the numerator. Okay? So this is a squared. Now here's the next one. If you have a root, the root is in the bottom of the denominator of the exponent. So the 2 is in the numerator, because if I take away the cube root, I take away the bottom part of that fraction. The 2 is still there. Okay? So this one, the 4 is the exponent, and the 3 is the denominator. Now we're going to get into where I'm going to give you 2 of these, and you're going to change them into fractions, and if you're multiplying, then you're going to add the 2 fractions together. And you have your calculator to do that. The calculator will add 2 fractions if at the end you press math frac. Okay, so you can do that. Okay, so here's what we have. We have a power that stays with the exponent, and the denominator is the root. So the nth root is what that's called, nth, the nth root. Okay, so here's 1. All right, the power is 1, and the root is the square root. So this becomes the square root of 3. The power is 3, and the root is 4. So this becomes the 4th root of 7 to the 3rd power, whatever that is, 240 something. Okay. So it's written like that, or it's written like this. Because, all right, now here's the reason that you can write it this way.
All right, if you have a root, that's the 1/4 power. So 3 times 1/4 is 3/4. All right, and this says take 1/4 of 3, which again is 3 times 1/4. All right, now negative exponent. Negative exponent puts it down here. All right, so what happens is that the 3 is the power and the square root, but instead of being in the numerator, it's now in the denominator. All right, that's the hardest one right there. Okay, now what is the square? This is square root. 1/2 is square root. So this is the square root of a plus b. All right, this is the trick problem because this is not times. So I can't separate the inside. It has to stay the same. If that plus sign was a multiply sign, then I could split that out and say the square root of a squared, which is a, times the square root of b squared, but when it's plus, you have to leave it there. Okay, now that's all the skills that you're assigned for 2 weeks. Isn't that nice? I saw that. In the mask, I still saw that. Yeah. Okay. All right, so let's turn over and let's look at this. Turn over to 247. 247. All right, we're gonna look at problem 11 to start with. Okay, get your calculators out. Okay, now the problem that we have right here is that we don't have a 5th root button on the calculator.
Aw,
Isn't that terrible?
that would be very helpful.
It would be. Okay, now first of all, go to math on your calculator, and if you'll notice, math frac we've been using. All right, look at the third one down. The third one down is a cube button on the inside in math, just like you have an x squared button that's on the outside. All right, x squared button is down just a couple of buttons below the math. Right, well there's a cube in there. So if it were helpful, as far as you're typing something in, to use the cube root of x, or the cube of x, is that you can use the 3. Now look at the one underneath it. Look at number 4. That's the cube root of x. So just like second x squared will get you the square root of, if you go math 4, you can do cube root of.
And if you want to change it, you can just go up to the corner and change the number.
Yeah. Now, number 5, I think you have to put the number in first and then press 5, and it'll give you that root. Right. So in this case for number 5, if we go back to the main screen with quit, second quit, and press the 5, and then go math number 5, and you should see, if you got a new calculator, it says 5th root. Okay, and then you would put in the 437, and you could get the answer. Okay, now, so if you did that, you should have 3.3736. Okay, now don't erase it. Don't erase it, because that's not the directions for this section. The directions for this section is use the reciprocal. Okay, so what I want you to write is 437 raised to. And the raised to button is over next to the divide by sign. Now, what power do we raise number 11 to?
The 5th?
The 1/5 power. So you put in 1 divided by 5 in the exponent. Yeah. Well, now press enter, and you notice you got the same value?
Yes.
Okay. All right. So life is better, is it not? Okay.
Yeah.
So now there's 2 ways. There's 2 ways you can do it. In the book, the reason that they're talking about the reciprocal power is that this book was written in the 1970s,
and the calculators like we've got were not in high demand. Well, they were in high demand, but people couldn't afford it. All right, because they were like $250 back when you could buy a television for that amount. All right, so now the 1/5 power. So now let's go to number 12. What are you going to do to that radicand, the number underneath? What are you going to raise it to?
1/8.
The 1/8 power, right? And so if you put in 58713 raised to 1 divided by 8, all right? Now let's see if we can do it the other way. It's the 8th power, so put an 8 in, and then go to math, number 5. All right, and I've got a newer calculator, and so it says 8th power. What do the older ones look like?
It still says the X.
It still says X, but you have an 8 right next
But
to
when
it.
you hit enter, it puts the 8.
It does, okay, good. All right, it does, okay. All right, so now we want the 8th root of 58713. Okay? All right? And 3.9454. Okay, now, all right, here's the reason why I think you need both. Okay, here's what we're gonna do a Pythagorean theorem problem. Okay, and we're gonna take the two legs of the triangle and we're gonna add them together. So the leg of the first triangle is 3.72, and we're gonna square that. All right, then we're gonna go plus 11.591, and we're going to square that. So that's a squared plus b squared. Now that equals c squared, so what does c squared equal?
148.
148, but I don't want that. I want c. So I have to take the square root of that. What power do I raise it to?
The second?
1/2 power. Right? So take that number and immediately press raise to and go 1/2, 1 divided by 2. And now you have, so you can take the square root of a number in a process without having to go back and type that number in again. Okay, now, all right, so that's one way. Okay, now, how do you get back up to that multiplication problem? Second enter. So go second enter, second enter. All right, now, change the 11 to 15 and leave the rest of the fraction, or the decimal there. Change it to 15. All right, so we made a mistake, and it was supposed to be 15 and not 11. Okay, so now press enter, and now we have 256.9176. All right, now wait. Store to x. Press enter, and it's going to repeat that number. Now, go second square root of x. Okay? Now, the first answer we got was 12.17, right? So let's go back up to that one. Go second enter, second enter, second enter, and second enter. And you have to do it 5 times till you get to 3.72 squared plus 11.591 squared. Everybody got that? All right, now press enter there. Now that's c squared. Store to x. Press enter, and then go second square root of x. And you get to 121733. Okay. Now, so in the practice of doing these squares and square roots, that type of ability can save you time on a test. Right? So to take the square root of a number, you raise it to the 1/2 power. Now there's 2 ways to write 1/2. We did 1 divided by 2, right? What could you put in? 0.5. Right? Which would have been even faster, because you can do 0.5 in 2 strokes, and 1 divided by 2 takes 3 strokes. Right? But
but it's a whole lot easier than going second square root and then having to take that number and punch that number back in. Right? And the way I just showed you, storing it to x and then go second square root of x is even faster than that, especially if the number has a lot of digits. Okay? All right, so, all right, having done that, then 13 through 18 now is pretty simple, isn't it?
Yeah.
All right, so it's just a matter of being able to work with the calculator. Okay, so now let's look at 19. All right, in number 19, the two numbers get multiplied. All right, so could you actually copy that equation, number 19, could you copy it in just like you see it? All right, do that. Copy it in just like you see it.
It's a very big number.
Okay.
58 million or something.
What?
How come?
Because we still have x stored.
Because our x, so the answer is what?
58 million.
No, that's not the answer. No, the answer to my question, can you copy that in? No. But what can we do? Okay, here's what we can do. We can say that the exponent is 5 plus negative 2, and we can put that in the calculator. Just tree. Right, so it's x to the third, and then we could put in 6 times 3, which is 18. So this simplifies to 18x to the third power. Okay, that makes sense?
Yeah.
All right, so what are you going to do with 20?
$56.
56, 7 times 8. All right, however you get that. And then if you did the a plus b, it would be x to the negative 3 plus 9. And negative 3 plus 9 is 6. So this becomes 56x to the 6th power. Huh?
It's a big number.
All right, but no, that's because you have the value for x.
You said
All right, no, wait, okay, all right, good. Now, all right, we got two people did that. All right, let's go, get on your calculator, all right, and let us write 0.2 store to x. All right, and you should see 0.2, right? Now, go second enter, get that equation back up, now press it. Now it's a tiny number. How come how did it change? The value of x is now 2/10 instead of being whatever it was, 180 or whatever that, no, it was 11 something, right? And so because we store a value into x, it's different than this type of problem. This type of problem, what you're doing is you're combining exponents in some form, either by adding, subtracting, or multiplying. All right? The x itself is a value that we don't know. It's true variable in this case. All right? Now, so let's look at 25. What are you going to do in 25? All right? You have to treat each parenthesis separate. So how would you simplify? And I'm going to do that on the board, just for the sake of our Rutledge people who are watching by video. All right, number 25 is negative 2x squared to the third power. Okay, so I have negative 2 to the third. That happens to be negative 8. And then I have x to the second raised to the third, and so I have 2 times 3, I have 6 x's, that's x to the 6. All right, I have simplified that first one. Now I'm going to multiply that by, and the second part of that is 3x to the negative 1, y to the second raised to the fourth. Now, 3 to the 4th, we already talked about. 2 3s is 9, so this is 9 times 9, that's 81. And then what happens here? I have 4 negative 1s. That's x to the negative 4th. And then I have 4 groups of 2, that's y to the 8th. Now what do I do with the 6 and the negative 4? What do I do with the 6 and negative 4? Add them. Why? Because they're being multiplied. Yes, Josh?
2 raised to the 4th is 16.
4 times 2 is 8.
Oh, right, I did that wrong, sorry.
Okay. Yeah, you were thinking of 2 down here. Yeah, okay. Yeah, okay. All right, now, so I have 6 here. 6 plus negative 4 is x to the 2nd, and the y to the 8th, there is no other, so it stays there. And then I have to multiply those two, and that's going to be 864 negative, because it's just 8 times 1 and 8 times 8. All right, and so that simplifies to this. Right, and it is just a step-by-step process so that you don't make a mistake. Right now, there's other ways to do that, but that's by far the safest way. All right, but you have to remember that the outside power of a power distributes, and this mathematics for the constant number is a different mathematics than for the exponents. Okay, now 32. 32. How do you get that x to the numerator?
You do the reciprocal?
Hmm?
You do the reciprocal with it?
Yeah, just do the reciprocal. So guess I don't need it there. The 7. Well, I'm going to get rid of this.
It was close.
Yeah,
Just went behind it.
If it was against the wall, I would have hit it, right?
Yeah.
Okay, so the 7 over x to the negative 5 is the same as 7x to the 5th in the numerator. And then it's minus 4x to the negative 3, is that what it was?
Negative 1.
Negative 1. That becomes minus 4x to the first. Okay, now, can I combine those and get 3x to the 4th?
Yes.
No! Because all I have in common is an x, and here I have 7x to the 4th minus 4. So these are not like terms, and so you can't simplify them. If they were multiplying, I could have done that. If this had been a time sign, then I would have been combining the 5 and the 1 to get 6. But because it's a subtraction sign, these are not like terms, and therefore it's already simplified.
So the most simplified version that you want would be the 7x to the 5th minus 4.
Yeah. But yeah, the reason that I started this is to show that when you pull out the common factors, that you don't have anything in here to combine. Right. Okay. All right. So now turn the page. Because we have a little bit of extra time, let's go over to page 251. All right. Now on 251. We have to remember that in a rational exponent where I have a and b, the x to the a power is the numerator and the root is here. So the denominator becomes the root. Okay? Everybody got that? So, on page 251,
to change problem 3 to a power, what does the cube root become as far as the power is concerned? Which power? All right, everybody say 1/3.
1/3.
1/3. You see why? Because the cube root will be the 1/3 power. Okay? Now, 64 happens to be 4 to the 3rd power. So here's what we have. We have 4 to the 3rd power raised to the 1/3 power. All right, so we multiply, what is 3/3? 1. And so this equals 4. So the cube root of 64 is 4. Prove that. You go second, go math, cube root, and put 64 in.
It is 4.
It's 4. Now, without a calculator, you can prove it this way. 64 is 4 to the 3rd power, and the cube root is the 1/3 power, and so I have 1/3 of 4 to the 3rd, which is 4 to the 1st. Okay? All right? Now, so, all right, look at problem 13. It's 64 to the 2/3 power. Now, was it 64 4 to the 3rd? All right, so therefore, this is 4 to the 3rd to the 2/3 power. What happens when you multiply 3 times 2/3?
The answer is going to be
The 3's cancel and you're left with
2.
4 to the 2nd, which is
16.
how much?
Oh,
16. Right? So the answer is 16. Okay, all of the problems in this section are done that way without a calculator. So here's the things that we need to know. All right, 64 is 8 to the 2nd power. So when can I use that? I can use that when I have a square root. All right? 64 is 4 to the 3rd power, and it's also 2 to the 6th power. Now, how did I get that? What is 4? 2 to the 2nd raised to the 3rd. It's 2 to the 6th. Okay, now, let's see, do we have those in this section? Or we may not. We're going to have those eventually. I don't have a calculator with me. All right, yeah, look at number 20. You see the square root? You see the 2/3 power in number 20?
Yes.
That's a square root. So which of these do I want to use? I want to use 8 to the 2nd. So because when I raise that to the half power, the 2's will cancel, and I'll have 8 to the 3rd power, whatever that number is. Okay. So 64 is 8 to the 2nd, and because it's also, now watch this. Isn't 8 2 to the 3rd? Isn't 8 2 to the 3rd?
Yes.
Right? And 2 to the 3rd squared is still 2 to the 6th. All right, so you can come at the 2 several ways. Now, what about 4? Okay, if I have 4 squared, all right, that's 16. Right? And 16 times 16 is 256. So 256 is either 16 squared or it's 4 to the 4th power. Right? And so if I have a 4th root, I want to use this. Now, what we have an advantage of is that we have a calculator that can handle fourth roots. All right, we just raise it to the 4/3 power, and then the calculator will get it out. But sometimes the directions don't allow that, and in this case, if you have to do it without a calculator, that forces you to actually do the values. What time is it?
11.
Oh, you got 10 minutes
Mark
left.
this down. We are done. Okay, so I've got a couple of things to pass back out, but I'm going to do that off camera. And your assignment is going to be 6-1 to 6-4, and it'll be up on the teacher page by the end of the afternoon.